Hello all, welcome to the subject of VLSI Design and Technology. I am Professor Meenakshi Panchal from Electronics and Telecommunication Department, Parathibai, Gyanma Moshi College of Engineering, Babuli, Pune. So today we are going to begin with a new unit, that is unit number 3rd. The name of unit is PLD Architecture and Application. PLD Architecture and we can write application. So let's discuss first topics in this unit is the digital design implementation and technology. The different technologies used in the implementation of this digital design, those are discrete device technology and application specific integrated circuit and PLD technology. First, we will going to discuss with the discrete discrete device technology. So in this discrete design technology, the fixed function ICs such as multiplexer, demultiplexer, addresser, comparator, code converter, shift register, and counter. So those are used to design the digital systems, and these systems includes the discrete logic gates and specific Boolean transfer functions and memory elements. So we will going to see the design flow of discrete device technology, which includes first device design specification, design specification, and second one is truth table. Third one is Boolean expression. Implementation on board. So this is the design flow of the discrete device technology. The design flow of this technology is as follows. The figure shown in a slide, and the system design specifications are listed first from the requirement of the system, and from the design specification a truth table is generated. Each row of the truth table is converted in the form of Boolean expression using an Boolean algebra or K-map, and this expression is then implemented on the digital trainer board using a fixed functions digital ICs. Let's see the advantages of discrete devices technology. First one is the development cost is lower. Let's see the advantages. First one is cost lower. And second one is faster turn of the design. And third one is easy to test the circuit. Easy to test the circuits. These are the advantages. Let's see a few disadvantages. First one is the design requires larger board space. Means it requires a large space. And second one is the power requirement is also large. Means high power requirement. And third one is the circuits can be copied by other. So the circuit can easily copied by other. And the last one is to modify the design and additional features are required. If we want to modify the design, what we require, additional features are required. So these are few disadvantages of discrete design technology. Let's see the second one, application specific integrated circuits. The second one is application specific integrated circuits. So to overcome the disadvantages of discrete device technology, the design are developed by using application specific integrated circuit, which offers a low cost solution if large quantities are assigned, but we rolled out as they can not easily accommodate change without incurring the significant and remasking charge. Once the production from the foundry has commenced, they also require high and non-recurring engineering cost and high annual production volume to be economic, either as a semi-custom or full custom. This is all about the application specific integrated circuit. Let's see advantages and disadvantages of this. The space requirement is lower. Requires. Second one is the power requirement is also low. And the third one is the cost is considerably low for mass production. The low cost. And the use of high level of integration reduces the cost. Reduces the cost and the design can't be copied. Even the design cannot be copied. The disadvantages. The development cost is also large. Development cost is large. And second one is the testing efforts are larger. If you want to test the circuits, we have to put lots of the effort. So testing effort, or we can say large. These are advantages and disadvantages of the application specific integrated circuits. So let's see third one, PLD technology. What about PLD technology? PLD technology. Programmable logic device is an integrated circuit which is user configurable and capable of implementing logic circuits. PLD is nothing but programmable logic device, and it's a type of integrated circuits which uses a configurable and capable implementing logic circuits. And the PLD integration chips with a allow designer to customize it for the system, and PLD can be programmed for the different applications. These are all about the PLD. Let's see a few advantages and disadvantages. Let's see what are the advantages. Time to design is lower, means it requires less time for design comparing the others. And second one is the development cost is low. Low development cost. And third one is board space requirement are also less. Less space required for developing purpose. And power requirements is also low. Low power requirement. Then fifth one is design circuitry is worthy. The design circuitry is worthy. And switching speed is large. These all are advantages of the PLD technology. Let's see disadvantages. Disadvantages. So what are the disadvantages? So before seeing advantages, we will see advantages over discrete or A application specific integrated circuits. The integration density is large. Integration density. Second one is production cost is low. Third one is high design security. Third one is reduced power requirement. Reduce power requirement and reduce space requirement. These all about advantages of PLD over application specific integrated circuits. The PLDs are flexible and can be programmed in a second. The programmable logic device can be used for the developing the application specific integrated circuits in the fabrication laboratories. In order to carry out these, the prototypes of the programmable logic devices should be developed by the designers. In this chapter, the detailed architecture of programmable logic devices have been discussed, and the programmable logic devices included in this chapter are programmable read-only memories, the programmable logic arrays and programmable array logic, simple programmable logic devices and complex programmable logic devices, and field programmable gate array. Let's see About the evaluation of this PLD, programmable logic device. In all the programmable logic devices listed in the above section, the first programmable logic devices developed in the programmable read-only memory. In programmable read-only memory, the input provided to the digital circuit are worked as the address lines and the outputs of the digital circuit are worked as the data lines, and those PROM is an inefficient programmable logic devices for the logic circuits. The first device developed for the implementing the logic circuits is the field programmable logic array, which is simply called as a PLA. And PLA consists of two levels of the logic gates and the programmable AND plane followed by a programmable OR plane. And also in a PLA, the input are logically AND together in AND array, and each AND array output correspond to the product term of the input. Further, each or array output is configured to the produces the logical sum of any of the AND array output, and which is also used for the implement logic functions in some of the product form. So I will show the figure of categorized PLDs indicating the logic capacities available in each of the three categories. This is the PLD categories by the capacity. In this architecture, the main problem is requirement of the programmable logic planes. Many commercial PLD products are available in a market with the basic structure are known as a complex PLD, that is known as a CPLDs, and which are manufactured initially by the Ultra in various series such as a Max 5000, Max 7000 and Max 9000. The largest capacity general purpose chips are Max programmable gate array, and those are nothing but array of the transistor which forms the logic circuit with the help of custom connecting interconnect. All these uh, mask programmable gate arrays are not in a category of the programmable logic devices. They are used in a field programmable gate array. So let's see PROM. So what are about the PROM? So let's see about PROM. PROM is nothing but programmable read-only memory, which is a device that includes both AND plane and OR plane within a single IC package. Out of these two arrays, AND plane is fixed or OR plane is programmable. I will show in a figure. Just a minute. So the first figure will show the block diagram of PROM. In mask PROM, it is necessary to specify the bit pattern to be stored according to the requirement of the circuit. Since PROMs are used in a logic design, and these are also referred as a PLDs. And the figure 2 shows the 4 into 2 ROM with a NAND and OR gates. And the another figure will show 4 into 2 ROM with a AND OR inverter gates. So let's see few advantages of ROM and PLDs are as follows. As no minimization of the logic circuits is needed, the circuits can be designed easily, and it is possible to modify the circuit faster, and these are high speed as compared to discrete circuits, and cost is also lower. These are all about the PROM. In the next slide, we will see about the PLA. So this is a PLA. The PLA. A PLA is a consist of and or array on a single chip. Both the arrays are programmable, shown in a figure. Here, first figure. The number of and or gates are their inputs are fixed for the given PLA chips. The AND array provides the product term and the OR array logically sum of the product term and thereby generates a SOP expression. SOP is nothing but sum of product, and the AND array is used to form the product term. And the figure second will shows the AND gate which has all the inputs variable in complemented uncomplemented form, and it has nichrome fuse link in a series with each diode. The OR array is used to provide the sum of the product term output of the AND array, and the sum of term are generated by the opening the fuses. When all the fuses except the one of the product term P0 and P1 are blown off of the output S0, then the equation will become S01, that's equal to P0 plus P1. Here, therefore, the OR array is programmed by the opening the fuse, which makes logical level low at the corresponding OR inputs. Here, the figure shows PLA diagram, which is having 3 inputs. The third one here, second one is there are having a 3 inputs, 4 product terms and 2 outputs. Here AND gate is AND array has 6 inputs and connection to an AND gate is a programmable. The PLA seems to be efficient in the term of area needed on the chip, and hence PLAs are often included as a part of the larger chip. The PLAs can be used to implement the combinational and sequential logic circuits. The Some of the steps we can see use for implementing combinational logic functions on PLA. First one is draw the truth table, derive the Boolean expression, modify the equation and to get it in a SOP form, and find the input connection of the AND array to generate the product term, and find the input connection of the OR array to generate a sum product. Find the connection required for the inverter non-invert array to set up the output. We have seen that in a PLA logic, both AND and OR arrays are programmable. Further, the programmable switches has 2 difficulties for the manufacturing, that are PLA are hard to fabricate and PLA reduces the speed performance of the circuits, and those new architecture AND array is programmable or or array fixed in a developed. So this device is known as a programmable array logic devices. Since PLAs are easily manufacturable and less expensive, PLAs are popular in a practical applications. A most commonly used type of PLD is a programmable logic arrays. So here the figure shows the first figure shows the block diagram of PLA, and the which illustrate the and this figure is a block diagram of PLA, and this second one is configuration of the and or array of the PLA with the with five inputs with five inputs and eight programmable AND gate. There are total eight programmable AND gates and four fixed OR gate. These are four fixed OR gate, and AND gate has a 10 input with a fuse which can be programmable to generate a 8 product term, and the number of fuses in a PLA are the products of 2m and n, where m is the number of input and n is the number of the product term. The most of the PLAs are the additional circuit is added with the fixed OR gate array, which is probably or popularly known as a macro cell, and the flexibility that is provided by in a macro cell is given in this figure. And these are the commercially available PLS. Some of the commercially available PLS ICs with their features is shown in this table. So let's discuss the next topic, that is simple programmable logic devices. The PLDs such as PLAs and the PLDs such as PLS, the PLS are simple PLDs. The programmable logic devices such as the PLAs and PALs are having less number of the input product term and output. Therefore, logic circuits that we need for more input and output SPLD chips are to be used. The most popular SPLDs are PLS produced by the advanced macro devices, and in a short form we can say AMD, popularly known as the 16R8 and the 22V10. Both AMD's devices are industry standard and are widely used by the various companies. The 22V10 architecture shown in a figure represents a breakthrough in a VLSI industry, and macrocells should be configured by the programming the state of the configuration bits. The configuration bits allows the macrocells input in a form of sum of products, and polarity of the macrocell output can be chosen. The programmable macrocell have feedback to use as an input to the logic array, and the feedback is directed from the register or the IO buffer, and further the output enable product term is programmed such as an output is always disabled, allowing the IO to be used as an input device. And the figure second will shows the structure of SPLD. Here the top and bottom macrocells are allowed 8 product terms and the middle macrocells are allocated 16 product term and the other are allocated 10, 12, 14 depending upon the location. And another widely used SPLD is a Ultra Classic EP6110. These devices is similar in a complexity to the PALS and offer the more flexibility in a NAND and OR gate in EP6110 output and which are registered and the flip-flops are configurable. In addition to SPLDs mentioned, many other products are available from a wide array of the companies which includes AMD, Ultra and ICT, Lattice, Cypress and Philips at Extra. So in the next slide, we will see the design flow and design entry and functional gate level simulation.